Hello, in this episode, we'll solve neural network using Keras functions. And there are two methods, and we'll cover the sequential method. So for this illustration, we'll use data from Kaggle, the lone default data. So let's go to Kaggle. So Kaggle has many data sets. And if you look lone default, you can get it. Actually, I did save the link here. You can go for this lone default prediction data. And if you click the download button here, it will download a zip file and you can unpack it. I already did on my computer. So what you'll get is default FIN file. It has 5 columns. Index, that's just a serial number. There are 10,000 loan information. The second column is whether one is employed, 1 or 0, unemployed, the bank balance of that individual, and your salary. And then finally, the one that we want to predict, whether it defaulted or not. If it's 0, not defaulted. If it's 1, defaulted. Okay? So it's always good to have a good idea to take a look at the actual data, how it looks like. It doesn't seem like it has any missings. Any neural network solution, the approach is first we load the data and then define a neural network model. How many nodes, how many layers, what activation function we'll use. So here we'll use the Google provided package, the sequential method. And then you compile the model, meaning what kind of losses, how you're gonna measure the losses of the prediction, what kind of optimizer you're gonna solve it. I'm gonna do stochastic gradient descent or here Adams or any other method. Okay? And then we fit the model, which is actually using the data points to run it in the neural network, get a prediction, compare it with the actual Y, the output, and then if there's an error, try to backpropagate to fix the error and update the weights and so forth. So a process of finding the optimal weights in the neural network. Once you have done, you evaluate it, meaning you put the X and Ys and then see how accurate they are. And then you can make a prediction using the trained neural network. Given an X, make a prediction. So this is generally the process it works. So here we'll go through and I prepare the file. So sequential method. The first step is, of course, import libraries. We have NumPy, Panda, TensorFlow. And then inside the TensorFlow for the sequential method, we're gonna use the sequential, and then we're gonna use the dense layer, okay? So let's have that. So let's load the data. So the data is lone default data, and can do this. Earlier episode shows you how to use Google Colab, how to upload your local file. If you basically type these 2 lines and run it, it will ask you for a local directory where the data is. You upload it on Google Colab and then have Panda to read in its data frame. So DF is the data frame I'm using. It is always a good idea to check the data. So what are the column names? And I already saw that there was a question mark in one of the names. I don't like it, so I want to replace it with deleted. Any space I want to delete it, I want to put it into lowercase. So here we go. These are the original, the top lines are the original names of the column names. After I convert them, it's all small capital, no space, and question mark delete. I also don't need the index column, which is the serial number. So I'm gonna delete it. So I'm just gonna use the employed, bank balance, annual salary, and default it. Okay, are there any missing data? There is an A method in the Panda. Fortunately, nothing. So even if I drop it, I keep everything. Are there any duplicates? So the duplicated method, and it says there's nothing. So I just keep all 10,000 observations. All right, so once I have it, I want to set the training variable to my X and Y variables, Y being what I want to predict, the defaulted. I can do it either in data frame or NumPy array. Let me do it in NumPy array. So the DF is a data frame, so I'm converting it to NumPy. So call it X. On the X, the last column, the column index 3, which is the defaulted, I'm putting it as Y. And the inputs are from 0, 1, 2 column. So I express it like this. We'll go to my X. And you can always check it. My X, let's see how it looks like. Yep, I have 3 columns. My Y, how it looks like. Yep, I have that defaulted indicator. So now it's the real thing. So once you have cleaned up the data and you're sure the data is clean and usable, then the next step is to set up your neural network. In an earlier episode, we showed you how to manually do it like a matrix multiplication. If you have 3 layers, then you need to have 2 neural networks, for example, matrices, and you have to match the dimension for the matrix multiplications and all that. And Google engineers have provided a neat package, and here is one of them. It's in the TensorFlow, the sequential method. And the way you use it is that first call the sequential method and save it in some variable. Let me name it model. So this model contains the whole structure, how the neural network is looking like. Now I have to design it. Every time I want to add a layer, I do model that I named here, .add, and then for now, I'm going to just use fully connected layer, which is called dense. Okay? So the dense, the first one, you have to specify what the input looks like. And that actually you don't have a choice. My input data has 3 columns, the X. Hence, the input dimension should be 3. But then I have a freedom of how the next layer, the first hidden layer looks like. And let me have 5 fully connected nodes, so 5 here. If I want to add another layer, before I do this, the activation function after that, let me just have a rectified linear unit, relu. What that is that it's like a hockey stick plot. So whenever the X variable is below 0, it just is 0. And when it's larger than 0, I'll just give out that value here, okay? Mathematically maximum above 0 and X, basically. Okay. If I want to add another layer, now I don't have to. The program already knows what the earlier layer looked like. So how many nodes do I want to add? I could have 5 and then activation relu. I can add another layer. But so if I want to add even more layers, I can just do the following. I can make it even like 10 nodes and so forth. So you can keep doing it. All right, so but let me just have 2 hidden layers. That's enough for me. And the final layer is output. Here, I'm having fully connected, but I don't have a choice of how many nodes I will have because my Y variable has actually single dimension. So the output node has to be 1. And the value of the output is between 0 and 1. So let me use a sigmoid, the logistic function activation, which ranges between 0 and 1. Okay. So it's very simple. Sequential, call it and save it in some model, some name, my model, something. And then keep adding model.add and then dense layer of how many nodes and just keep doing it until you end. Just be sure that the input and the very last layer output has to match up with how your data looks like. So now that the computer knows in my model variable how the network dimension looks like, I have to compile it, meaning that set up the initial weights, what kind of a loss function I'm going to use, how am I going to measure it, what kind of optimizer I'm using. So I'm going to use binary cross entropy when the prediction variable is a classification, binary classification, like 0, 1 variable. Binary cross entropy is a common choice. And basically is, well, entropy, cross entropy. Maybe here. Does it give me a nice, Let me find a nicer picture, binary. Okay, here. So if my variable is p, let's say between 0 and 1, then p log p minus 1 minus p log 1 minus p, which looks like this. People look at it as an entropy function, okay? All right. And so the maximum here or the minimum is where we want to be, the losses. Okay? All right. Anyway, so it turns out that binary cross entropy is usually a good choice when you are trying to predict a 0-1 variable. Instead of gradient descent, we use a more efficient Adam optimizer. If you want to use stochastic gradient descent, SGD is what you do, okay? Nothing wrong with that. It's just that this performs a little better. So let me just use this. And the metric I'm going to use on accuracy. Okay. So the next one is actually use the X and Y variables to fit, meaning optimize the weight, find an optimal weight using the back propagation. Epoch means that I'm going to use the X and Y data over and over again. Yes, you can do that. And usually we do this multiple times. This time I'm going to use run the data 50 times, the same data 50 times. And I'm updating the weights every 10 observations. So I first compute the errors and accumulate it for 10 observations, and then update the weight and keep doing it. Okay. So let me do this. Okay, it's gonna run for a while, for 50 times running it, and you can see the accuracy keeps improving. Okay, it finished running all 50 epochs. Okay. So after you train the network, so now it has found the optimal weights for the neural network we designed. You can use the evaluate method, put the X and Y variables. It will give a prediction of the neural network and compare it against the actual Y here and gives an accuracy, how many % of the times, fraction of the times it got it correct. Turns out 96%, okay? 96% of the time, it correctly predicts the default. Now that you can just use a prediction to give just the X variable and predict and see the predictions and see how that leads to, compares to the actual. And for these here, for given X, it predicts 0 and all that here, it correctly predicts them. So this is all it summarizes. Load the data, define the model, compile, and use the data to fit the optimal weights, and then you can evaluate and then make predictions. And this is how you use it. And you can see that Google makes it very easy. The TensorFlow makes it very easy to do learning network. By the way, if you have just one hidden layer, it's a shallow neural network. Like what we did, if you have more than one hidden layer, like 2 hidden layers, it starts being called deep neural networks. So it's fairly straightforward to do actually plain deep neural networks. Thank you for watching the video.